Okay, so in this video, we are going to look at some manipulatives that we can use in order to model fractions. So we are going to start with pattern blocks. So I'm looking at the activity that is on page 137 through 140. So to introduce you to the pattern blocks, we have these 6 pattern blocks we are going to use. So we have the yellow hexagon, the green triangle, the red trapezoid, the brown trapezoid, the purple triangle, and then the blue rhombus. So we can use these pieces to make fractions. So in a minute, I'm going to have you try this activity on your own, but I did want to try at least the first one with you. So it says, if the yellow hexagon is one whole, which block shows, and then it has all these fractions. So if this represented 1, which of these pieces would represent half of that size? So that is going to be the red trapezoid. So if you take a look, if you had 2 red trapezoids, if you just keep one of them, then that is half the size. So the goal here is, again, if you're thinking about parts and wholes, so which shape would split this into 2 equal parts, and then you have one of those parts. So this one is the, oh, it's hard for me to write. So red trapezoid. Okay. So then for 1/3, which of these shapes would split the hexagon, if that's the whole, into 3 equal size pieces? So that's going to be the blue rhombus. So if I did that, it takes 3 blue rhombi in order to make the hexagon. So if I just have one of those pieces, this is 1/3 of the size of the yellow hexagon. So blue rhombus. All right, the next one, what about a 4th? So which piece would split the hexagon into 4 equal parts? So that is going to be the brown trapezoid. So let me steal this one from up here. So just to show you, it would take 4 of them to make the whole. So if we just had one of them, that would be 1/4 the size of the whole. Let me put that back up here. So brown trapezoid. Then 1/6, which shape would split this into 6 equal parts? So that's going to be the green triangle. So there's 3 of them. Here's the other 3. All right, so it takes 6 triangles to make, 6 green triangles to make the hexagon. So 1/6 would be one of those 6 pieces. So green triangle. And then finally, 1/12. Which piece would split the whole into 12 equal parts? So that's going to be the purple triangle. So let me just scooch this up here. So you see it takes 12 purple triangles to make one hexagon. So 1/12 would just be one of the purple triangles. Okay, so what I want you to do now is I have posted a website for you that links you to virtual manipulatives, so virtual pattern blocks. So I want you to go ahead and try the pattern block activity. So again, it starts on 137. It goes all the way through page 138, and then the top part of page 139. So visit that website, use the pieces, and answer these questions. And then when you are done, come back, and then I will go over the answers. Okay, so now that you're back, after you've tried this activity, I just want to check your answers with you. So for number 2, if the red trapezoid is the whole, which block would be half of that? Well, the one that chops it in half into 2 equal parts would be the brown trapezoid. So now I'm realizing I forgot to mention that The brown trapezoid was not included in the pattern blocks on that website that I gave you. So hopefully you were still able to figure that out even though that piece is missing. Okay, so what about 1/3? Which one would split this into 3 equal parts? That's going to be the green triangle. So the green triangle would be 1/3 of the size. 1/6 is going to be one of the purples. So since it would take 3 green triangles to make the trapezoid, it takes 2 purples to make a green. So 1/6, it would take 6 of these. So that one will be purple triangle. All right. And then if this is 1, the whole, what would represent 2? So technically 2 would be 1, 2, which is the same thing as the yellow hexagon. It's twice the size of the trapezoid. So that one would be yellow hexagon. All right, next one. If the blue rhombus, if that is 1/3, what block would show the whole? So if that's one piece you need, but it takes 3 to make the whole, that would be looking like that, which again is the yellow hexagon. All right. If the green is 1/2, which block shows the whole? So if you currently have 1 piece, but you need 2 of them to make the whole, that would be equivalent to the blue rhombus. So this one should be blue rhombus. And then if the purple triangle represents 1/2, which block shows the whole? So this is the 1 piece you currently have, but it would take 2 to make the whole. So 2 of them together is equivalent to the green triangle. So green triangle for this one. Okay. All right, on to the next page, 138. So more of these. Let's see. Oh, that's hard to read. Hold on. Move my pieces out of the way. So if the purple triangle was 1/3, which block would be the whole? So you currently have 1 piece, but it would take 3 of them to make a whole. So that would look something like that. So that is going to be equivalent to the brown trapezoid. If the purple triangle is 1/6, which block would be the whole? So you currently have 1, but the whole would be 6 of these. So that would be equivalent to, that's like 3 green triangles, which would be the same as the red trapezoid. So 6 purple triangles, so the whole would be the red trapezoid. All right, then it says if the yellow hexagon is the whole, draw or trace 3/4. So again, what piece would split this into 4 equal parts? That is going to be the brown trapezoid. Okay. So 3/4 would be 3 of those pieces. So your sketch should look something like that. Kind of like this, poorly drawn, but you get the idea. Okay, number 9, if the yellow hexagon is the whole, draw 5/4. So again, what piece splits the hexagon into 4 equal parts? That's the brown one. So this time you have 5 of those pieces. So your picture should look something like this. So you would have 5 of them. So let's see here. Quick sketch. Okay, so 5/4 should look something like that. All right, number 10. If the blue rhombus represents a half, what is a whole going to look like? So if that is one piece, but you need two pieces to make the whole is going to look a little weird. It's going to look something like that. So kind of two blue rhombi together. Okay. So now, these build upon each other. So if we know, sorry, paper's moving around. So if we know that is 1, that's the whole, what would 3/4 look like? So which piece would split this into 4 equal parts? So that would be the green triangles. So 3 of the pieces would look like this. Okay, so 3/4 is going to represent 3 green triangles. Now, this is important. So I expect to be able to see the value of 3 compared to 4. So you might tell yourself, well, 3 green triangles is equivalent to a red trapezoid. So can I just draw a red trapezoid? I would prefer you to not draw a red trapezoid because this is only one piece. So this would imply a fraction of 1 divided by something. And 3/4 is really driving home the fact that you have 3 pieces of a whole. So I would prefer if you did the 3 green triangles. Okay. Now over here that can't be avoided. So, all right. So again, going back to if this is the whole, 1/8. So which color would split this into 8 equal parts? That should be the purple triangle. So maybe I can try and do this really quickly. All my pieces, let's see. And whoops. Flying out of my hand there. Okay. So there's the 8 pieces. So 1/8 would be one of these pieces. And then I'm leaving this, I'm leaving this up here because then 3/8, again, that would be the purple triangle, but this time you would have 3 of them. Okay, so that would look something like that. So again, you might realize that 3 is the same thing as a brown, but I would prefer if you showed where the 3 pieces were coming from instead of converting it to a larger piece. Okay, so those should be your pictures for number 10. All right, what about number 11? So 11, let's see, if the red trapezoid is the whole, okay, what fraction, so now we're writing fractions. So a green would be 1 piece out of how many green triangles would it take to make the whole? That would be 3 of them. So 1 green would be 1/3. The blue rhombus. So let's see. So this is a tricky one also. So the blue rhombus would be there's 1 blue rhombus, and it would take how many to make the trapezoid? So it would be 1 full blue rhombus plus, if we look, this would be half of another rhombus. So technically this fraction would be 1 out of 1.5. So it's 1 blue rhombus out of 1.5 blue rhombuses would make a whole trapezoid. Now that's totally weird. So in this particular case, it would be okay if you convert these, and instead, if we split these into green triangles, we could say it would be 2 green triangles out of 3 you would need. So essentially all you're doing is doubling this fraction to make it less weird since you have a decimal within the fraction. So if I double this, it would be equivalent to 2/3. Okay. But technically, the blue rhombus would be the fraction 1 over 1.5. Okay, but let's convert it so it's a fraction that we know and understand. All right, what about 3 brown trapezoids? So if you had 3 brown trapezoids, you have 3 pieces, and it only takes 2 of them to make the whole. So we would have 3 halves. So 1, that would reduce down to be 1.5. So 1 full trapezoid equivalent plus half of another trapezoid. The yellow hexagon. So if this is 1, then over here this is double the size. So that would be 2. So it would take 2 of them. So if this is 1, this would be 2. 2 green triangles, so we already talked about this. Since that's the same thing as the blue rhombus, you have 2 triangles, and it would take 3 of them to cover the red trapezoid. 1 brown trapezoid, that would be 1 piece, and it takes 2 of them to make the red trapezoid. So brown is 1/2. And then what if you had 5 green triangles? So looking something like that. So we have 5 pieces, and it takes how many of those to make a red trapezoid? So it takes 3 of them. So we would have 5/3, which would reduce down to be 1 full trapezoid plus 2/3 of another red trapezoid. So 5/3 for that one. Okay. All right, next page. So we got 3 more. So if 12 says, if the yellow hexagon together with a red trapezoid equals a whole, name the fraction represented by the green triangle. Okay, so if this is 1, a green triangle would be 1 piece out of how many would it take to make this shape if this is the whole? So it's going to take 3, let's see, doing this upside down. Okay, so it's going to take 3 there, and I don't necessarily have enough pieces, but it would take 6 over here. So if it takes 6 here and then 3 more to finish off that piece, that's a total of 9 triangles. So 1 green triangle would be 1/9 the size of this shape. Let's see. If the sum of 2 green triangles is the whole, name the fraction represented by the yellow hexagon and the blue rhombus. Okay, so if this is 1, how much would be in this particular shape? So if we just travel around, so that would be 1, there's 2, there's 3, and there would be 4. Okay. So 8 green triangles total, and then if it takes 2 to make a whole, it's almost like saying 8 halves, which is the same thing as 4. Okay. And then this last one, if the sum of the yellow hexagon and a green triangle is 1, so if this is 1, name the fraction represented by the red trapezoid. Okay, so the red trapezoid would be what? Let's just see. So there would be 1 of them. Oops, threw that piece. There's 2 of them. So then let's see. Then there would be another 1/3 that is falling in here. So technically the answer would be 1 red trapezoid out of how many would it take to make the full shape? It would take 2 1/3 red trapezoids in order to make the whole. Okay. So again, this is another weird one where we have a complex fraction. There's a fraction within a fraction. So instead, let's break this one down into something simpler. So maybe I convert these into green triangles. So this would be essentially like I have 3 green triangles. So I'm just going to multiply this whole fraction by 3. So if I had 3 green triangles, then how many green triangles would be in the whole? So you'd have 3, 6, and then 7. So this is actually going to be 3/7. Okay, if we do a conversion. All right, so that wraps up talking about pattern blocks. Hopefully you got all of those correct or know why they are what they are. Okay, so next up are the Cuisenaire rods, so named after their inventor, John Cuisenaire. So pattern blocks that we just looked at are an area model because we were thinking about how much space they took up. So Cuisenaire rods are manipulative that are based off of length. So you should notice we have 10 different colors of rods and they are all at different heights. So ranging from 1 up to 10. Okay. So there are 14 questions related to Cuisenaire rods. So again, I posted a website linking you to some virtual Cuisenaire rods. So I wanted you to try this activity before we talk about them. But let me give you an example of like number 1. I know this is hard to read on my video. But it says, if the brown rod was the whole, so if that is 1, which rod would be 1/4? So which rod would split this into 4 equal parts? So I believe that's going to be the light green one. So if I got 4, oh, nope, not the light green one. Let's see, how about the red one? I misspoke. Let's see. So is it the red? Yes. Okay. So red splits the brown into 4 equal parts. So 1 of those 4 would be 1/4. So that is going to be the red. Okay. So again, pause this video, go to that website that I posted, try these out, and then come back to check your answers. Okay, so checking our answers. If the dark green rod is the whole, so which rod is 2/3? So which rod split this into 3 equal parts? So I believe that's the red again. So 2/3 would be 2 of these reds. And this time it wants to know what's the equivalent. So 2/3, we could either say it's 2 red, or what rod is also the same length as the red? So, nope, not yellow. So that's going to be the purple. So purple would represent 2/3 as well. Okay. All right, how about the next one? If dark green, I just put it away. If dark green is the whole, which one would be 3/2? Okay, so which one would split this into 2 equal parts? So again, I picked the wrong one. Let's see. So light green. So 3/2, you would want 3 of these pieces. So 3 parts, and it takes 2 of them to make a whole. So we could say 3 light green. Oop. Or which one is also equivalent to 3 light green? So that would be the blue one. So we could also say blue for this one. Okay. Let's see. If the red rod is 1/2, which rod would be the whole? So if this is one piece you have and you need 2 of those pieces to make the whole, the one that's equivalent to that would be purple. So purple would be the whole if red was half. All right, if red is 1/3, which one would be the whole? So if we had 3 reds, which one is equivalent to 3 reds? Is that black? No. So that's going to be dark green. Okay, so dark green would be the whole. All right, if light green is 1/3, let's see here, which rod would be the whole? All right, so you have 1 of them. You would need 3 of these to make the whole. So which one is equivalent to the whole? Is that blue? Yes. Okay, so blue. If dark green is 2/3, which rod is the whole? Okay, so this one's a little tricky. If dark green is 2/3, the dark green represents 2 pieces. So which one makes that into 2 pieces? Let's see. Nope. Oh, I'm sorry, I misread this. I'm using the light green and it's talking about the dark green. That's why it's not working. Okay, so let's try that again. So dark green is 2/3. So which rod splits dark green perfectly in half into 2 parts? That's the light green. Okay, so if that is the 2 pieces we need, and then we need a third one, so which rod would be the whole? So again, that's going to be the blue one. So the dark green is 2/3 the size of the blue. So sorry about that. Okay, if the yellow rod is 5/4, which rod would be the whole? Okay, so we would need to split the yellow into 5 equal parts. So I'm guessing that's going to be the white ones. All right, and then it only takes 4 of them in order to make the whole. So it's going to be 4 whites, which is equivalent to, is that purple? So purple. So purple is going to make the whole. Okay. Let's see, if the white rod is 1/4, which rod is 1 3/4? Okay, so if this is 1/4, this would be like 2/4, 3/4, 4/4. So that's a whole. I don't have any more whites, unfortunately, so let me just do this. So that would be the whole. And then we need 3/4. So 3/4 would be another 3 whites, which would be, let's see, green, I believe, light green. All right, so this would be 1, this would be 3/4. So which color is the same length as that? So I think this one is, oh, not brown. How about black? So black would be equivalent to 1 3/4. So black. Okay, if the red rod is 1/3, which rod would be 1 2/3? So if this is 1/3, it would take 3 of them to make the whole. So which one is that? Is that one black? Have all my pieces mixed up. Nope. How about dark green? Okay, so 1 would be dark green, and then we still need 2/3 more. So 2 of the 3 pieces extra, that should be purple. All right, so it's the dark green with the purple. So which piece is that? Let's see, it's not blue. Oh, it's definitely not brown. Let's see, is it orange? Yes, it's going to be orange. So orange would represent 1 2/3. All right. Okay, if the dark rod is the whole, what fraction is the yellow rod? Well, in order to compare these, you should make them into same size pieces. So I think white would be the easiest to use. And then again, I apologize, I don't have enough whites here, but so dark green, there would be 6 white rods in the whole, and yellow would be 5 of them. So yellow is going to be 5/6 of the dark green rod. The next one again, if the dark green rod is the whole, what fraction would blue be? So blue is going to be larger, right? So it's going to take 1 full dark green, and then how much of another dark green? So I believe what it is, the red splits the dark green into 3 equal parts. So you should be able to fit, oh, of course it's not going to work. So it's going to be 1 1/2. So we can't use those. So what about splitting these into white? So the blue rod down here on the bottom would be, let's see, So there would be 6 white rods in the whole. So that would be our denominator. And then how many of those white ones would it take to make the blue? So it's going to be kind of hard to see. So let's see. So 1, 2, 3, 4, 5. That would be 6. And then 7, 8, 9. So this should be 9/6, which reduced down to be 1.5. If the purple rod is the whole, excuse me, what fraction is the brown rod? Okay, so let's just see. So there would be 1 purple. There would be, oh, perfect, 2 purples. So if the purple was 1, brown is twice the size. So brown is just going to be 2. And then lastly, if the purple rod is 1, what fraction is the orange? Okay. So again, in order to do this, we want same size pieces. So I'm guessing we would have to split them. Let's see. Can we do red? Would red work? Yeah. So there would be 2 red in the whole. And then how many red pieces would there be for the orange? Let's see. 1, 2, 3, 4. And again, I don't have enough pieces to show you. I apologize. But that would be 5 reds to make the orange. So 5 reds in orange out of 2 reds it takes to make the purple. So orange is 2.5 times the size of the purple. So you should be able to see if I did this. So it's 2.5 of the purples. So 5 halves would reduce down to be 2.5. All right, so that is Cuisenaire rods. Okay, so we've looked at pattern blocks and area model. Cuisenaire rods are a length model. So then what about sets? So for this one, I'm just going to have to draw these out because I don't necessarily have a manipulative. So you could use like coins or counters or just anything really. So if we have 8 counters in the whole, so 1, 2, 3, 4, 5, 6, 7, 8, that represents 1. How many counters would be in 1/4? So if we chop this into 4 equal parts, one of the 4 parts would be 2. So there would be 2 counters if 8 was the whole. For 15, for number 2, which is 15, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. That's a whole. How many counters make 3/5? So you would want to chop this into 5 equal parts. So we could do that. And then if we take 3 of those groupings, 1, 2, 3, so that is going to be 9 counters. So that should be 9. Okay, on the back. If 9 counters are a whole, 1, 2, 3, 4, 5, 6, 7, 8, 9. How many are in 5/3 of a set? Okay, so again, if we split this into thirds, so 1, 2, 3. 5/3 would be 5 of these groupings. So 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3. So 5 groups. So that would be 15 counters. So 1 2/3. So 1 full grouping plus 2/3 more. So 9 plus 6. If 4 counters represents a half, how big is the set? What would the whole be? So 4 counters is 1 grouping, and you would need 2 of those groupings. So 2 groups would be 8 counters. So just doubling, that one should be pretty straightforward. Number 5, if 12 counters are 3/4, I didn't give you a lot of room to do these. Let's see. 3/4. So split this into 4 equal parts. So 1, 2, 3, 4. Oh, I'm sorry. I'm doing this wrong. My apologies. Let's try that again. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. My apologies. So it's 12 counters are 3/4. So you currently have 3 equal groups. And it would take 4 of those groups in order to make a full set. So if we add 4 more, a full set would be 16. So 12 is 3/4 of 16. Okay. Number 6, if 10 counters are 5 halves, so meaning you have 5 groups. We are trying to figure out how many groups are in the whole or one set. So you currently have 5 groups, but it only takes 2 of those groups to make a set or the whole. So 2 of those groups would be 4 counters. Okay, so 4 counters. All right, number 7 in the whole set has 6 white counters and 3 that are black. What fraction of the set is black? And it says don't answer in ninths. So what is another way that we can do this? This would be one grouping, one grouping, one grouping. So 3 groups all of the same size. So the black counters would be 1 of the 3 groups. So this would be equivalent to 1/3. Okay. Or if I did allow you to say 9, so it would be 3 out of the 9, which reduces down to be 1/3. Number 8, let's see. 10 counters are in the whole set. So what fraction of the set would 6 counters be? Let's see. So 6 counters would be this many. So a cheap way to do this is that it would be 6 out of the 10 that you have total. So something else you could do if you split these into equal size groups. If we split these, let's say, into groups of 2, you would have 5 groups. So 6 would be the 3 of the 5 groups. So that would also reduce down to be 3/5. Okay. And then the last one, 16 counters are what fraction of a whole set of 12? Let's see. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So 12 is the whole. So if this is the whole, then 16 would be what fraction? So to make 16, you would need 1 full group of 12. And then you would need 4 more. So again, lots of ways you can think about this. So you either have 16 counters and there's 12 counters in the whole. Let's see, if I split these into groupings of 4, there would be 3 groups in the whole, and 16 would make a 4th group, so it could be 4/3. So just reducing that fraction down. I could split these in half again and make 12 be 1, 2, 3, 4, 5, 6 groupings. And adding 2 more additional groups would be 8 groups. So it could be 8/6. So there are lots of possible answers for that one, for those. So now I'm realizing I should have told you to try these before you looked at the answers, but that's okay. So then finally, drawing rectangles. So we've done that in our previous activity that I just went over in the last video. So again, you can feel free to try these before you watch the rest of this video, but if not, that's all right. So number 1 says draw a rectangle, and then it says show 2/3 of the rectangle. So that means the whole would be 3 equal parts, and then you have 2 of them. So 2/3 should look something like that. Draw any rectangle. Show what 5/3 would look like. So again, the whole would contain 3 equal parts, and then you are going to have 5 of those pieces. So we actually need a second rectangle. So 5. It's going to look something like that. For number 3, draw any rectangle. If this rectangle is 1/3, what would the whole look like? So if that is one piece you currently have and you need 3 of them to make the whole is going to be 3 rectangles. Number 4 says draw any rectangle. If that rectangle is 3/4, what shape would be the whole? So if this is 3/4, that means you have 3 equal sized pieces, but it is going to take 4 of those pieces to make the whole. So your whole rectangle should look like 4 of those pieces put together. Okay, and then finally, draw a rectangle. This rectangle is 4/3, so we're kind of flipping around the last one. What would that rectangle look like? So if this is 4/3, that means you have 4 equal sized pieces, but it only takes 3 of them to make the whole rectangle. So this one is going to be a little bit smaller. Okay, so again, rectangles would be another example of an area model that we could do. So this is just, again, a review of some fraction models using manipulatives. So there will be questions like this on your upcoming test. So if you have any questions, let me know. And this was another long video, so thanks for watching.